Welcome back, students. This is the Q&A session 4 from the playlist of JEE Advanced Part 1. The chapter is Units in Measurement and the topic is Error in Measurement. The question which I have taken for this session is written on this board, and this is the question which was asked in the JEE Advanced paper in the year 2017. So here the question is, a person measures the depth of a well by measuring the time interval between dropping a stone and receiving the sound of impact from the bottom of the well. The error in the measurement of time is equal to 0.01 seconds, and he measures the depth of the well, which is equal to 20 meters. The fractional error in the measurement of delta L by L is close to. So these are the four options here: 2%, 5%, 1%, and 3%. And we have to find the correct option. Here the speed of the sound which is given in this question is 300 meter per second, and the value of G is 10 meter per second square. So in this question we will have to first of all find the total time taken, or you can say the time interval before the man hears the sound of impact. So this is the depth of the well, which is given as L, capital L. So the time interval before the man hears the sound of impact. So this will be equal to the time taken by the stone to reach the bottom of the well, and then the time taken by the sound to reach the man. So the time taken by the stone to reach the bottom of the well can be calculated by using the equation of motion for constant acceleration. So one of those equation is given by S is equal to ut plus half at square, half gt square in this case. So here S is equal to L, which is the depth of the well, and the initial velocity is 0, so this term will be 0, and we will be getting half g t square, where t is the time taken by the stone to reach the bottom of the well. So t is equal to under root of 2L upon g. Let us take this t as t1. Now, after it reaches the bottom of the well, we have to now calculate the time taken by the sound to reach the man. So that let us say that time is equal to t2. So this will be equal to L, that is the depth of the well, divided by the speed of the sound, which I have taken as equal to c. Okay, so I am just taking the speed of the sound as c, which is equal to 300 meter per second. So the time interval t will be before the man hears the sound of impact will be equal to under root of 2L upon G plus L upon C. Okay, now here the most important thing here which we have to see is that delta t is tending towards 0. Delta t is almost, it's not 0, but it is tending towards 0, because the value of this delta t is equal to 0.01 second, which is very close to 0. So we can say that here that delta t is tending towards 0. So therefore what I will be doing is, now I will be differentiating this equation with respect to L. So dt upon dl will be equal to, this 2 and g are constant, so root 2 upon g is constant. So I will be getting it as 1 divided by 2 root L. ठीक है, because after differentiating this term with respect to L, I will be getting under root 2 upon G. This is a constant, divided by 1 upon 2 root L plus, here C is a constant, so I will be getting here, I will be getting here as 1 divided by C. So now it implies that dl upon dt, this is equal to 1 divided by root 2 upon G into 1 upon 2 root L plus 1 upon C. Okay, from this equation with what I have got this equation, that is dl upon dt will be equal to 1 divided by under root 2 upon G into 1 upon 2 under root L plus 1 upon C. Now, so it implies that dl is equal to dt divided by under root 2 upon G 1 upon 2 root L plus 1 upon C. Now since here we see that delta t is tending towards 0. Delta t is almost, it's not equal to 0, but delta t is tending towards 0 because delta t here is equal to 0.01 second. So I can rewrite this equation as delta L is equal to delta t divided by under root 2 upon G 1 upon 2 root L plus 1 upon C. So this equation can be rewritten as delta L upon L, which is equal to delta T upon L, because I am now dividing this equation on both sides by L. So this will be equal to under root 2 upon G into 1 upon 2 root L plus 1 upon C. So this is the final equation, and now we have to substitute the value of G, delta T and C in this equation in order to get the value of delta L by L. So it implies that delta L upon L will be equal to, delta T is equal to 0.01 divided by L is equal to 20. This is equal to root 2 upon G. So G is 10, so this will be equal to 1 by 5 into. This is equal to 1 upon 2, L is 20. So 20 can be written as 5 into 4. So this will be equal to, now 4, the under root of 4 is 2. So 2 into 2 will be equal to 4, and I will be getting it as 4 under root 5 plus 1 upon C. The value of C is given as 300 meter per second. So I have substituted the value of C as 300. So delta L upon L will be equal to here 0.01 divided by 20, and this will be equal to what? 4 into 5, which is equal to 1 upon 20 plus 1 upon 300. Now here you have to see one important thing, that we have to find the fractional error in terms of percentage. So what I will be doing here is, I will be multiplying this equation on both sides by 100. So delta L upon L into 100, this will be equal to 0.01 upon 20, and the value of this will be equal to, I will be taking the LCM of it. So 300, this is equal to 15 plus 1, and since I have divided this equation on both sides by 100, so this will be equal to into 100. Now delta L upon L into 100 is the fractional error in the measurement of this delta L by L in percentage. So the value of this will be equal to that. This is equal to this will be, that's 0.01 into 100, that is equal to 1, and this 300 will go into the numerator. So 300 divided by 20 into 16. So this is equal to how much? This cancels out, 15. So this is equal to 15 upon 16%, and which is very, very close to 1%. Because here the fractional error in the measurement of delta L by L is close to, means approximately equal to. So there are 4 options: 2%, 5%, 1%, and 3%. So our correct option is C, which is 1%. This one. So the correct option in this case is the option C, which is 1%. So in this way we have to solve this question. Here the most important thing which we all have to remember is that we have to form the equation in terms of the total time taken by the total time before the man is able to hear the sound of impact. So thank you very much for joining this session, and in the next session I will be coming up with another question, but it will be based from the topic of either vernier caliper or screw gauge. So till then, have a nice day. Bye.